Okay, so basically we're going to go over the lessons that you probably learned back in 4th and 5th grade, but just apply these to algebraic fractions and also understand why the rules work. So without going into too much detail, I think we all agree that to multiply two fractions, you multiply the numerators and multiply the denominators. The big thing here is you can also reverse that process if it's convenient for you. Okay, so let's say you had AC over BD, and for some reason you wanted to separate the A and the A over D from the C over B. Okay, that's a legal move to do, factoring part of the numerator and factoring part of the denominator out from the rest of the fraction. From time to time that becomes convenient. So it's taking this rule and reversing it that is not always obvious to people. Let's take a look at an example. So we're going to multiply these two fractions together. That means multiply the numerator times the denominator, but we can be discrete about how we do that. We can be selective about how we do that. Let me start by factoring the numerator of the first fraction as x plus 3 times x minus 1, and factoring the denominator of the first fraction, which is going to give you x minus 3 times x plus 1. Okay, so now you have 3 minus x, 3 plus x, and the rule says let's multiply these things together. So I can do that, and we'll get one big chain in the numerator of 3 things, and one big chain in the denominator of 3 things. Okay, now what I'd like you to get used to doing is not slashing things out, but noticing where you have some unnecessary ones. So for example, a x plus 3 and a 3 plus x would come out to be a 1 if you divide them, as long as x isn't negative 3. And so the principle on the previous slide says I could take that outside of the rest of the fraction if it's convenient for me. Okay, and it is. The other thing you can take out is a 3 minus x and an x minus 3. I'll explain that in a second, but let's just write it this way. 3 minus x and an x minus 3. And so what are you left with? You're left with an x minus 1 and an x plus 1. Now, what's the point of rewriting it this way? Well, the point is this. Okay, this is really a 1. As long as x isn't negative 3 and you're dividing by 0, you're okay. But that simplifies to be a 1. It's unnecessary in the fraction, so we don't need it. What about this 3 minus x? Well, I need to recognize that 3 minus x and x minus 3 are related. If you factor out a negative 1, you would get negative quantity x minus 3. And so this fraction is really an unnecessary negative 1. So when it's all said and done, this big mess simplifies to be negative x minus 1 over x plus 1. Now, if you just blindly jumped in and multiplied the top times the top and the bottom times the bottom, you may not have recognized all the things you could have done to arrive at that answer. Adding fractions with like denominators. So there's a principle in math that says you can only add things that are the same. So for example, 3 apples plus 2 apples you can add, but you can't add 3 apples and 2 oranges, okay, unless you convert them to units that are the same. Okay, so you can add 3 apples and 2 apples. That's good. You can't add 3 apples and 2 oranges unless you convert them to common units. Same thing happens with fractions. So when we talk about fractions, we distinguish them by their denominators, like denominations of religions, right? So these would be seaths. A seaths plus B seaths would give you A plus B seaths. Since they have the same denominator, they can be added. Now, we're all familiar with that, I think, but what we're not familiar with all the time is reversing that rule. Okay, for some reason, reversing that rule in the United States is hard. So if you have A plus B over C, or A plus B seaths, that can be split into A seaths plus B seaths. Okay, this is a big, big, big rule that we use over and over again, and you got to recognize it when you see it. Okay, but you have to be aware that the reverse is not true. If the sum or the difference is in the bottom, the denominator, you can't split that. That doesn't work. So let me show you some examples where this comes up. Simplifying 4x plus 2 over 8 can be done by doing 4x over 2 plus 8 over 2, if that's convenient for us, and a lot of times it is. So I took 4x halves plus 8 halves, and I just split it. I know that I can add them back together to get to the original problem if I need to, but this could be simplified to be 2x plus 4. More complicated example, but same principle. This could be split. 4x squared over 2 square root of x plus 3x over 2 square root of x plus 8 over 2 square root of x. This is convenient from time to time. In calculus, it's very convenient when you're doing what's called a derivative. You want to do this. So this simplifies to be 2x to the 3 halves plus 3 halves, x to the 1 half plus 4. I could leave it in the bottom or write it as 4x to the negative half, depending on what I was doing. Okay, adding fractions with unlike denominators. So now we're not in a position to add these together because they are different units. These are a bths and c dths, so they're different things. They can't be added together as they stand. So how do we make them have common units? Okay, and the answer, and something that we do all the time to expressions to make them look different but actually be the same, is to multiply by 1. Okay, but we multiply by 1 in a clever way that helps us out. Okay, when you multiply by 1, the value of an expression does not change. Okay, so we would like to have these two fractions to have the same denominator. There are many same denominators they could have. We'd like them to have the least common denominator. And so just this will always work. There may be a smaller one, but this will always work. If we get the denominator b times d, then we'll have common denominators. So d would need a factor of b, so we multiply the first fraction by 1 in the form b over b, and we multiply the second, or this fraction in the form of 1 by d over d. Okay, this puts us back to the last slide where you multiply multiply numerators and multiply denominators, and now you have same units. You have b dths, and so when you have like things, you get like things. So we add the numerators, but keep the denominators the same. Now, applying this to algebraic fractions is no different. So we don't get intimidated, we're doing the same thing. These do not have the same units, same denominators, so we need to create same denominators. We do that by multiplying by 1. One way to do that is to multiply top and bottom of this fraction by x minus 1, top and bottom of this fraction by x plus 1. That effectively is not doing anything to the value of the expression, but it's definitely changing its appearance. So we have x plus 1 over x plus 1 times x minus 1. Could you multiply that out? Sure, you could. Plus x minus 1 over x plus 1 times x minus 1. Denominator is now the same. These can be added together. So x plus 1 plus x minus 1 over x plus 1 times x minus 1. The 1's cancel, 2x is left in the numerator, and if you feel like it, you can multiply out the denominator, but you don't have to. Okay, now these always bother people, but if we understand the basic principle here, we'll have no problems. Okay, compound fractions, a fraction divided by a fraction. This is ugly, right? This is bad style. Okay, this would not make it on your reality TV shows. You get booed off the stage. So how do we fix this? Well, I would like it if this denominator was a 1, right? Then it would be just one fraction. So how do we make a denominator of 1 here? Okay, well, I could get a denominator of 1 if this was something over itself. So I could do that by multiplying by d over c. You'll notice now you'll have cd divided by cd. But we just learned that if I do something to the bottom, I better do it to the top as well, so that I'm really multiplying by 1. So now the bottom becomes 1. I'm not worried now, and I just have fraction times fraction in the numerator. AD over B times C. So look what we did here. We took A over B, I'm going to write divided by C over D, and we ended up with A over B times D over C. So this is where that rule you learned in middle school comes from, flip the guy and multiply, right? When you divide fractions, we multiply by the reciprocal of the second fraction. That's where the rule comes from, that's why it works. Okay, so we do this all the time. This is ugly looking, but if you think about it, it's just A over B over C over D. In other words, it's the same thing as 2x squared minus 3x minus 2 over x squared minus 1, it's minus, divided by, right, divided by 2x squared plus 5x plus 2 over x squared plus x minus 2. So what does that mean? Well, the rule says flip the guy and multiply. I now know why it works, so I'm confident with it. 2x squared minus 3x minus 2 over x squared minus 1 times x squared plus x minus 2 over 2x squared plus 5x plus 2. Multiply by the reciprocal instead of divide. Okay, now what are we going to do? Am I just going to multiply these blindly together? No, I want to be smart about this. So if I can, I'd like to factor and see what kind of work I can avoid doing, because maybe some things are nice here and will disappear. Okay, so let's sit over here because I can quickly see that this factors as x plus 2 and x minus 1. I know the denominator over here is x plus 1 times x minus 1. I'm going to need a 2x and an x here, and also a 2x and an x here. Let's see, can we get maybe minus 2 plus 1 and plus 1 plus 2? Okay, now let's rearrange things. So I noticed that I have a 2x plus 1 in the numerator of the first fraction and a 2x plus 1 in the denominator of the second fraction. So I'm going to pull that out front. I have an x plus 2 in the numerator of the first fraction. So let me mark off what I'm doing here. I've seen that. I've seen that. I'm now looking at this and this, right? So x plus 2 over x plus 2. Okay, I notice an x minus 1 and an x minus 1. And now the only things left are an x minus 2 and an x plus 1. Beautiful thing, this is a 1 as long as x is not negative 1/2. This is a 1 as long as x is not negative 2. And this is a 1 as long as x is not 1. So my simplified expression under those restrictions is just real simple. I like it. Okay, so just real quick, two other forms of compound fractions. You could have a over b all divided by c, which is really c over 1. So this would be really simply a over b divided by c over 1, which would become a over b times 1 over c. So in the end, you get a over bc. Okay, so understand that c is going to end up in the denominator. This is why. So if you have something like this, 3 over x minus 1 all over x plus 2, this would become, on the next line, 3 over x minus 1 times x plus 2. Once you get to the point where we can just jump to this line, but in the beginning you may need to think about it in this context. Or you might have a over b over c. Okay, well that's no different than saying a over 1 over b over c, which is really saying a over 1 divided by b over c, which would become a over 1 times c over b. So in the end, you end up with ac over b. Again, it's like multiplying by the reciprocal. So for example, you might have x minus 1 over 2 over x. What happens in the end is you end up with x minus 1 times x all over 2.